This is an electrolytic method to improve antibiotic potency and solubility.
Lyophilization is a process where an antibiotic is frozen then sublimed to increase its stability over a long duration of time. However, this can lead to a decreased solubility in water, resulting in difficulty passing through the GI tract, causing uneven concentrations and low bioavailabilities at infection sites. This project seeks to determine the effects of reconstituting an antibiotic with electrolyzed water to improve concentration of dissolved antibiotics, increasing the bactericidal effectiveness of the antibiotic, modeled with the Kirby-Bauer method on Serratia marcescens, Escherichia coli, Staphylococcus epidermidis, and Bacillus subtilis. As stated, lyophilization increases stability but decreases solubility to water, causing incomplete bacterial eradication and low bioavailability. The azithromycin monohydrate is an example of one of these antibiotics that is lyophilized, and that's why it was chosen for this experiment. Below are 4 bacteria modeling infections that azithromycin may be prescribed to treat. Electrolysis is a process where an electric current is flown through water and generates hydrogen and hydroxide ions at the cathode. Hydroxide ions in the presence of azithromycin compounds leads to depronation of amine groups, increasing its solubility in water. It also disrupts the hydrogen bonding network of water, causing pH to increase and average cluster size to reduce. Smaller water clusters have fewer hydrogen bonds, allowing these molecules to freely position themselves around ions with closer interactions between ions and water molecules, facilitating the formation of hydration shells around ions.
The hypothesis for this experiment is that if azithromycin powder is reconstituted with electrolyzed water instead of regular distilled water, it will have a greater zone of inhibition due to reduction in cluster size, increasing solubility of water to polar compounds. On the bottom left-hand side, you'll see a graph comparing the pH stability of treated water and untreated water. And on the bottom right, you'll see the variables for this experiment. Please pause if you'd like to read.
My full procedure can be found on my research plan. However, on the left is preparation, and on the right is testing and growth. The top photos were taken of trial 6 of all 4 bacteria. The bottom left shows my positive control groups, and my bottom right shows my negative control.
7 trials were taken for my 4 bacteria, and in Bacillus subtilis, there is an increase in the treated versus untreated as shown by the blue graph on the left. However, this was not statistically significant with a p-value of 0.087. And on the right, you'll see my Serratia coli showing a very significant increase in p-value of 0.005. The graph on the left, representing Staphylococcus epidermidis, showed a large statistical increase from a mean of 2.229 to 3.057 zone of inhibition in millimeters, showing that our hypothesis was supported and had a p-value of less than 0.001. Serratia marcescens on the right also showed an increase from untreated to treated, with a mean of 2.386 increase to a mean of 3.157 with a p-value less than 0.001, supporting the hypothesis. In blue, you'll see Bacillus subtilis, which was poorly responsive to azithromycin and did not improve significantly from this experiment, having a p-value of 0.087. In red, there were a large increase in means from regular to electrified water, increased from 2.4 to 2.802, and had a p-value of 0.005. And in yellow, Staphylococcus epidermidis in regular water had a mean of 2.229, increased and electrified to 3.057, with a mean p-value of less than 0.001.
Of most importance from the data, Serratia marcescens, a bacteria that is highly resistant to azithromycin, showed the most increase in mean zones of inhibition from untreated water to electrified water, going from a mean of 2.386 millimeters increased to 3.157 millimeters, with a p-value under 0.001, supporting the hypothesis. In conclusion, my hypothesis was supported by each bacteria, however, less significant in Bacillus subtilis. If this experiment were repeated, it would be advisable to test the effects of electrolyzed water reconstituted with azithromycin on more common strains it's used to treat, such as chlamydia or pneumonia. As per application, electrolyzed water may also aid in the solubility of other compounds hard to dissolve, such as creatines, wax compounds, and other crystalline compounds. Thank you.